Today, I'm looking at this family Stenostygnidae, which belongs to the group, the Samooidea, and I'll kind of show you what we've learned about this family and tell you a little bit about why we think it's a good candidate for testing biogeographic hypotheses in the West Indies. So that's really my two objectives: to first start by providing you with our new perspective on this family Stenostygnidae, which we're proposing to raise it to the new rank of family level. It's previously been a subfamily. And then second, to look at why it is a good candidate.
Sorry, Dan, we saw all your slides. It is a normal view for your press?
You see this?
Yeah, I saw all your slide presentation.
You're not seeing the full screen?
No.
Ah, okay. Let me go back out and reshare.
It looked like there was an option that said use slideshow.
Yeah, I think it was in presenter view, right? Now you see the full screen?
Yes.
Okay. Yeah. All right. So yeah, these are my two objectives. We previously had Stenostygnidae as part of the family Biantidae, and this family had problems because of the typological approach used by Rover and other authors. So that Roverian system that you've heard so much about in this talk, in this whole session, we tend to criticize it, but of course he was working with what he had at the time. But generally, species that lacked a common ocularium and they had these very elongated pedipalps. You can see an example one up here in the top right. So this very elongated pedipalp with an unarmed femur, an unarmed tibia, and then, or unarmed patella and very elongate patella, then the armed tibia and armed tarsus with these long setiferous tubercles. So this was very characteristic of species that were classified as Biantidae. The dorsum was also often armed with these spiniform apophyses, and the family Biantidae was distributed pretty widely across Southeast Asia, Africa, including the Neotropics, while other families belonging to Samooidea were only from the Neotropics. So the Stenostygnidae and the Samooidea being other families, these three families making up the Samooidea. Within the family Biantidae, the only one that was neotropical was Stenostygnidae. It had 9 genera, 17 species, and then the rest of the Biantid subfamilies were in Africa and Southeast Asia. So we looked at these three families of the Samooidea and asked, are they monophyletic? And under this current taxonomic system, none of them are. So we see Biantidae split into one subfamily, the Biantidae, all of these from Africa. And then we have this nice monophyletic group of all these other taxa that are from the Neotropics, which include the Biantid subfamily Stenostygnidae, Stygnomatidae in several different parts of the tree. So it's not monophyletic, and neither is Samooidea. So all of these families turned out to not actually be monophyletic the way we view them. So that same tree, and you can see the tree down here in the bottom left still without the taxa, that same tree is now recolored to show you how we would group these species into families based on this tree as well as the morphology of these groups. So we have our Biantids from Africa, and then we have this monophyletic group, which is all neotropical. And this neotropical group, we can split into at least 5 families. We still have several taxa that are Incertae but we generally can group these based on morphology, especially penis morphology, into these 5 families. So I'm going to focus on the Biantidae. Well, I'm going to focus actually on the Stenostygnidae, which were previously part of this group, Biantidae. So they get a new rank. We have a new family here, a new family here. And of course, we used morphology to differentiate these and diagnose them because someone might look at these and call these one family together, but based on morphology, we can see a clear split between them. So we have this distribution, this really interesting distribution of the Biantids in the Old World, and they're very diverse, spread throughout Africa, Southeast Asia, Madagascar, some of the islands in the Indian Ocean. And then we have Stenostygnidae in the Neotropics, some of them in the northern parts of South America, in Mexico, and in the West Indies. So we have an interesting group here that we're going to focus on in the Neotropics. But of course, I want to say that this group over here in the Old World could have the same complex history and could be, and certainly is, great material for future studies, right? Because we only have 5 species sampled, all from Africa, but it would be really nice to have samples from these other places in our phylogeny. So the Stenostygnidae in the Greater Antilles, this is Heterolacurbs. It's a pretty typical species of Stenostygnidae, and this is where most of the diversity occurs, at least the known diversity as of today. So a lot of species, 8 genera, 17 species in the West Indies. Many of them look like this. They have these spines on the dorsum, these eyes that are separated. They're not on a common ocularium. It has many of them have a scapula, and many of the taxa in this family now also have this organ on the 3rd leg, which is a sexually dimorphic glandular organ found only in the males, and its function is still unknown, but it's a very interesting structure that can help us to actually differentiate the families as well. So we have this, this group that I just mentioned in the Greater Antilles, and Stenostygnus was previously known from South America, but with our kind of new additions and systematic revisions to this family, we're learning that this is actually a really good group for biogeographic studies in this region, because we now have 2 new species of Stenostygnus, which I'm going to show you from Venezuela here. We also have a genus which we need to revalidate called Flaccus from Mexico that belongs to this family. We have another genus from Colombia. And so the diversity of this family is much greater than previously known, and its distribution offers an opportunity to look at biogeography in the Caribbean. How did they get to these islands? And I'll talk a little bit about that in a minute. So we have this interesting distribution of Stenostygnus. Now I'm focusing in on this one genus just within South America. And we have Stenostygnus pusio. For a long time, this was the only member of this genus. It was monotypic, but it is no longer, because we now have a second, well, we have a new species 1 and a new species 2. We don't have names for them yet, both here from Venezuela. And this is really the work of Vanessa to describe these 2 new species. Vanessa is working with Abel, and they're working on describing these 2 new species, comparing them to the original Stenostygnus pusio. But here are some of the major differences that we can see on exomorphology of the body. We've got differences in how the body is armed. So in this one, we have no tubercles between the eyes. So this interocular region is smooth versus tuberculate. This one is smooth. Then you can see differences on the areas of the body. This one with tubercles here, and smooth here. And even along this posterior margin, there's many more tubercles on these 2, and it's pretty lacking on this one. So those are just some of the differences we can see on the bodies. You can also see the body shape is somewhat different. This one's more rounded, where this one is more square or rectangular. And we can also see differences in the legs, in the pedipalps, and the genitalia. And so these are all different characteristics that we're using to differentiate these 3 species. But the important part is that we now have 3 species in South America that belong to this genus. It's no longer monotypic. On the patella of leg 4, we can see some armature, some moderate armature here, a really long spiniform apophysis here, And in this one, it has the tubercles, but it also has these really large tubercles on the tibia. So we see some armature differences between the species. And then if we look to our Mexican clade, the genus Flaccus is quite diverse in parts of Mexico, probably extending down into other parts of Central America, but we know it mostly from southern Mexico. It was previously the reason this is, many of these species are described, but they're currently described under the genus Stygnomma, and they belong to the family Stygnomatidae. And so we've discovered through our phylogenetic analysis that it really is related to the Stenostygnidae. The reason it wasn't placed there is because it doesn't have the same typical pedipalp. It doesn't have that very elongate femur without the armature, the elongated patella without armature, but it does have these long setiferous tubercles on the tibia and tarsus. So it shares some characteristics, especially in penis morphology, but it doesn't share the same palpal morphology, which is probably why it was placed in Stygnomma and not with the Stenostygnidae.
12 minutes, Dan.
Okay, so we have this this family in Central America that is the Stygnomatidae. The true Stygnomatids are actually not as well sampled in phylogenetic studies as we thought, because most phylogenies were using Stygnomma that are actually now Flaccus. So so we're kind of seeing a better picture, a clearer picture of the diversity of this group. Okay, so why are they interesting for Caribbean biogeography? The Caribbean is quite complex in terms of its history. Over the last 100 million years, islands have come and gone, but none have persisted for that long. 65 million years ago, a huge meteor struck what is now present-day Yucatan Peninsula. 45 million years ago, islands started to emerge that then persisted. So land masses were persistent in the Caribbean since that time until today. This allowed for dispersal and reverse colonization. And then for a couple million years, right around 35 million years ago, it's hypothesized that there's this land bridge, Garlandia, which extends from South America up through the Greater Antilles. And so taxa like this, like the Stenostygnidae, offer a good opportunity to test hypotheses like Garlandia and look for events of dispersal and reverse colonization between the islands and the mainland. And so we have somewhat of a preliminary analysis using a dated phylogeny. And we do see that the diversification of this group, this family, sort of aligns with the emergence of those islands in the Caribbean. They reached the islands. We only have one taxon in this tree from the islands, but it splits from its South American relative roughly 38 million years ago. So it could potentially offer some insight on Garlandia. But the important part is that we have representatives in Mexico, in South America, and in the Greater Antilles, and we can sample them more thoroughly and really test these hypotheses a bit better. We also have interesting correlation between the split of the African Biantids with the whole Neotropical clade, and that could that lines up pretty well with the split between South America and Africa as Gondwana began to break up about 100 million years ago. Okay, so I'd like to say thanks to my colleagues at the museum in Argentina for putting on this Congress, but also I worked there for 2 years with them, and a great group to work with. Thanks to the Carbio team for providing many of the specimens. And yeah, thank you all.